All right, so as Donnie said downstairs, there's a fan coil unit here, and there's a fan coil unit that's above the compressors. The thermostat for this one here is on this back wall, and we can walk down and show you where the thermostat is for the one that's located down here. So pretty much you have a fan that's going to be off. If the temperature rises above the set point that is adjustable at that thermostat, the fan's going to come on. The fan's going to come on, try to bring the temperature down to thermostat to set point based on the thermostat, and then when it goes below its differential, it's going to end up shutting it off. And that's pretty much the operation of it. If there's a fan failure, you'll get a fan alarm, and it just has a chill water valve. It's a modulating valve. It's not a two-position valve. So that's pretty much it for the fan coil unit.
It's just fraud is mechanical on that side.
That just serves this area over here, and then the one that's down here just serves the ones above the by the Cabelco compressor.
And the one in the sub-basement does the electrical switch gear downstairs. There's the same unit.
Oh, okay.
So there's 3 of these. They're all same size.
Okay.
The only
main switch gear room downstairs.
The only difference between that one and these ones is these ones shut off on temperature. The one downstairs constantly circulates the air downstairs in the electric room.
Okay.
So these ones will come on when it goes above set point. The ones down there, the fan will continue to run.
Is that the one that's constant?
So pretty much just the standard VAV fan power terminal that you have throughout the hospital. A lot of the patient rooms have the fan power terminals. You know, other areas in the place are just going to have a standard VAV box. So they have a supply return, then offset. So the exhaust is going to track what the supply is doing pretty much. Typical with these rooms, you have the fan, you have your regular flow. If you guys want to take a look at the graphic here, you can see how the graphic is set up. But it's pretty much you have, these rooms will have humidity in them. You'll have air changes. And they'll have a differential, you know, a DP across it, so you'll get an alarm if the pressure in the room goes positive or negative, depending what type of room it is. Again, you'll have your set points, your min maxes, your radiant panel. That stuff hasn't been done yet because that was something that we were going to end up changing in the end as far as the program change. So. So you have, like I said, you have your set point adjustments, you have your humidity high-low, temperature high-low set points, your pressure alarm set point, your air changes, and a fan alarm. So if the fan fails, you'll get an alarm on that, unlike the VAV box that obviously doesn't have the fan in it. But pretty much the VAV and these are going to be all controlled the same way, minus the fan.
All right, I've got a question.
Mm-hmm.
So when we finally get this half of the wing, it's all going to be balanced and everything's going to be, you know, in an ideal world, picture perfect. 3 or 4 years from now, or from whenever we get it, I'm up here doing the room maintenance, and I notice the room's negative. I'm under the understanding that the rooms need to be positive to the hallway.
Mm-hmm.
What do I adjust on this, in this building, to make this room positive?
Well, this would be that set point that Charlie just adjusted. So
Yep.
he went, this
So
was...
it's the same as the other building?
Yeah, it was 250 before, right, Charlie?
225.
225.
You bumped it up to 400?
Yeah,
Okay.
so the design is 75 CFM for the restroom, and
Uh-huh.
net 150 for the room. So you have
Okay.
you got a 225 as a design offset.
Okay.
So on these for us, you obviously see your min and max.
Yeah.
So whatever your flow set point would be that you would see here,
Yeah.
you would just you would subtract this, and then that should be your flow for your exhaust. That's what you would want your set point to be for the exhaust.
Okay.
So right now, my flow set point, my actual flow is just about 400 with the
Yeah.
set point of 400. So you see my exhaust set point is 0 because I'm subtracting 400 from that, which is giving me the set point to this.
Right.
So now if we went back to 225, I hate these things. 225. So now you should see
My exhaust
225 off of that. So it should be like 275.
There it goes.
Oh, I'm sorry, 175. And then that's gonna, the exhaust is gonna end up coming up and tracking up to maintain that. So if you ever seen the room that was, you know, too positive or too negative, or however you wanted to get it to track, you can adjust that
Yes, you said-
differential set point, and that will end up changing what you need to change.
Okay.
But again, those numbers that you're gonna see there were balanced. That was the offset they
Came up with.
that they needed in the room,
Yeah.
you know, so.
Yeah.
I mean, I guess,
Well, see, I always have another issue about that is, you know, like I said, 3-4 years from now,
Sure.
there's been a bunch of different changes and whatnot. I'm just doing this room to the hallway. I'm not saying the hallway's right, I'm not, you know what I mean? So
Yep.
for me, it's kind of sort of like a sliding scale, so to speak.
Yep.
You know what I mean? I just want to make sure what I'm doing is the right thing.
yep, that would be the number you would want to change on it, yeah.
Cool.
You have your duct temperature, your pressure in the room. Like I said, there's a Cetra that's in there that's referencing, as you can see, the standard pickup tube that we use in here. So there's one here, and there's one that references the hallway. So that's your pressure, your air changes, your humidity. These sensors are a combination.
Okay.
So if
Interesting.
you do change the sensor out, if you feel that one of them is bad, you want to
have
make
to
sure
calibrate
that
it?
you. No, you shouldn't have to calibrate it when they come in, when you put one in. But it's over here. I don't have my control screwdriver with me, but there are 3 HT instead of the S3.
Okay.
So there's an S3 sensor that's just the temperature, and then there's a 3 HT that's the temperature and humidity.
Okay.
So if you replace that with just a temperature
Make sure
one,
you're
because
gonna
they
get
look
the-
exactly the same, you're not going to have
Okay, I see what you're
your
saying.
temperature's
You're taking
not going to.
some of the
Yeah.
readings out. Okay.
So that's going to be gone.
Now, when you say gone, will it just be 0 readings there, or you won't see any of that? at
No,
all?
you'll see it. Yeah, it won't read.
Okay.
Yeah,
Alright,
that's
so that
not
way
gonna
they
go
will know you did something wrong.
Right.
Will that bring in an alarm if you had that hooked up?
Yes, because you have, well, your humidity high and low settings.
Yeah.
So
Okay.
These fan power boxes, do they have a 3-position switch, or is it set at 1 speed?
the fans are set for 1 speed, per what the balancer is set them up for. So they're not going to change once we turn them on. Whatever they're set
I
at.
think they're back pressure modulating though, right? Bonnie, can you help me on that? Don't they have a fan that adjusts for the filter loading? Sorry, I should have done a little homework on that.
I'm just
I couldn't
wondering,
remember.
can somebody go up there and just say, hey, you know what? And turn the knob, not knowing that they're not supposed to touch them.
No, there's no.
It's not a
main speed
3-position
on-
switch, it's
on
just
the
wide
outside, no.
1 speed.
I think so. I don't know, is there a screwdriver setting in there or
To be
something?
honest with you, I haven't paid too much attention to them because when
That's a good question for the balancer.
I start it up,
Price boxes?
I make sure it goes on.
Uh,
I'm sure it goes off.
Some of the newer type. is
Okay.
circuit board. There's pots on there you can adjust.
Just being honest.
Right.
Screwdriver for the speed.
Right.
That's the pneumatic room you're talking about, right?
No, some of the newer technology, fan power boxes,
Uh-huh.
they don't have like the old ones, like a speed switch
Yeah,
on the side
yeah,
or
yeah.
a rheostat or something. A lot of them, it's just you open up, there's a circuit board in there.
Okay.
There's little tiny, like, potentiometers in there,
Uh-huh.
and you can use a little screwdriver, you can adjust
Really? Oh, okay.
fan speed up and
Oh.
down.
Yeah, some of the
That's
motors
how
have
most of them are, so
some of the
preset
motors have
by
the
them.
like a BAS thing that you can actually bring a speed to,
Okay.
and the ones that don't, like Jim said, they just have like a little jumper in there, and then you can dial it in to where you want it to be if it doesn't
Are
match.
they ECM?
Like an ECM motor, yeah.
Are they these?
I'm not 100%
Yeah,
sure.
some of the newer technology ones they have, I know some of them I've seen recently. Depends on, I don't know what they have up there, but some of them you adjust the price ones that you can adjust the fan speeds. The last time I did something with the balancer up on 11, they had put fan power box in, that's what we were adjusting. I had to adjust it. I had to get up there, when too much air was blowing, so I had to open up and there's a little circuit board. Took a little tiny pocket screwdriver, you can adjust the fan speed. On the circuit board.
Yeah.
It's not something to be obvious, like if somebody showed us, didn't know what they were doing, they wouldn't have any idea, because you gotta open up these like little panels.
Yeah, you gotta have,
You gotta look at the
that's one of those
instructions.
things where you have enough information to be dangerous.
Yeah.
Yeah,
You know.
I just don't wanna see the, medium, low, high.
Right.
I don't recall seeing any
Yeah, I
fan
don't
speed
think-
switches up
Not
there.
anymore, they use the little pots on circuit boards.
No, no generic, the old fashioned switch.
Yeah, like I said, somebody goes up there, bang, next thing you know,
No, it's
you're
not.
hesitant on what, about moving it or not moving it.
One thing we confirmed they have here, though, they have backdraft dampers on the return. So if the fan goes down, if it fails, if you gotta work on it, you're still feeding primary air to it. So all the dust you collected on the filters
It's not gonna drop
will
down.
blow back into the room. You have a nice little dust cloud if you turn the thing off. It's got a little backdraft, it's like a canvas cloth kind of flap. You guys may have that in your on the other part of the 6th floor, but that's a good feature to have. You don't want it to,
Yeah,
especially in a room like this.
Well, we don't have that in the main building.
Yeah, oh, you don't have it.
No, we found out the hard way.
Find out the hard way. If you do,
If you shut the fans off and the air handle's still running,
Yep.
back feeds.
Blows everything you collected on your
Blows
filter.
everything. That was a big snowstorm.
And the immune suppressed patient's room, it's not a good thing. So here, we won't have that.
And all of these VAV boxes, they ended up changing them out. A lot of them had, some of them had the standard pitot tube set up, and then some had the ELFs, the Ebtrons, for the patient rooms, but they ended up going with the ELFs on everything.
So
So
everything
everything
has
has
ELFs.
ELFs,
Okay.
yeah.
Let me just put these into, we're gonna go with the Certers.
You get the Ebtrons with the slab box, swing down, right?
They,
The what, the
Walls,
Ebtron
yeah.
goes on the return box?
I didn't think so. I thought
Yeah,
they
they have
was
the
gonna use
clamp.
The Certers. They're always easy
Oh,
to
the
get to,
electronic ones?
All of them, everything.
So they have
Should have no
both.
problem.
They got a visual
Yeah.
for the staff.
so they changed it, right? 'Cause I didn't think.
There's both, yeah. We have
Don't worry,
Yep.
kind of questions.
don't worry, we get the small
Oh,
HVAC
0.08, yeah.
guy right over there now.
One of the things when we go through the commission.
Ryan the mouse.
Right now.
Yeah, what?
Go open the door, make sure it goes to 0.
Yep.
You know, so it's
Ryan's
one
gonna
of
be
the
eating a
parts
lot
of testing
lately.
we'll be doing. We'll measure that too.
And like, you know, just in the past with myself and Buddy, all of the thermostats, I'm gonna sneak in here.
I'm sorry about.
All the thermostats, if you take them off, they all have the TB number that's referenced on the mechanical print, and they have our file number on it, which should match up, which you would end up seeing. So if you guys were ever to come in here after we were, you know, completed, and you guys need to do service on it, and you needed the file to come in here, and you wanted to make a change and update it so everybody else had the same file, that's the file you would grab. And then you'll notice on the bottom of all the boxes, they all say the same thing. You'll see something that says RB, A, or C, and those are the routers. Each floor has 3 separate routers on them, the Ilon 600 routers, and everything has less than 30 devices on each router to kind of keep everything at a minimum. So if you're looking for something and you're trying to connect up to something and you're plugged into an RC controller, and you're trying to see an RB, you're not going to see it. You're going to have to you have to move to an RB or an RA, unless you do the global thing where you can kind of see everything on it. But again, these are going to be up on the boxes. Every box is going to have all the same numbers on it. So if you're not sure which box you're at, the thermostat, everything is tagged up in the ceiling.
Transformers for VAV boxes. You're familiar with that whole change, right?
Yes, that's a good point.
You want to touch on that, or?
We have a print that has locations. Steve Kirkpatrick is going to have the locations of where all the transformers are. I'm not 100% familiar with where exactly they are, so I don't want to walk around and start popping the tiles. They are all documented on a print, but I just don't know off the top of my head where they all are. There was a power issue on the floor of the type of circuit that was ran that had to be in pipe. And the solution that the hospital engineering, everybody came up with, is that they put in transformers. So we have 3 to 4 transformers per floor. So the VAV boxes have 24 volts going to them.
So it's 110 at the transformer.
It's 110 at these transformers that you'll have in the hallway,
From the transformer.
and then they use the existing wiring for the 24 that's powering up all of these. So you're not going to have 110 volts per VAV with the transformer. So if you lose the transformer, we built the panels that you have a spare transformer right next to the other transformer. So if you guys come in here and you find the transformer's blown, all you have to do is just lift a wire and move it over, and you're back up and running. And then you just need to pull that old one out and replace it. So there's no, well, this is blown, let me go run and try to find one. It's already set up there with you. And there's inline fuses in there. So Transformer could be good. If you have a controller that's bad, you know, something that's shorted out, it's going to blow that fuse before it blows the transformer.
Is it an individual inline for each transformer?
Yes.
For each controller? Or just one for the whole
Main for the
transformer?
main transformer.
So if you short something accident, hey, you gotta
You
take
could
down a bunch
potentially
of stuff.
you could
Yeah.
potentially
You
blow.
lose
fewer
multiple
rows.
boxes instead of a single box. So it's normally a transformer per box.
Yeah.
Right.
But because of the fire ratings issue, because it's on critical power,
Yeah.
we wanted it to be in conduit up to a single transformer. Now the transformer can feed out to multiple boxes on low
Right.
voltage without having to be in rated conduit. So,
The downside is you're gonna take down a few boxes if it happens.
exactly.
If you do something like
But
that.
at the same time, the failure scenario of these boxes, if you lose the power, they fail as is. So that's the beauty of it. You shouldn't wig out your flow and pressure.
Right.
And that was-
Is there a disconnect, is there a switch at each controller?
Yeah.
So I can shut off and you don't have to worry about showing something.
Yeah.
24s.
Yes. Each box has its own switch. Yep. We utilized all the same switches for it. Yep.
Yeah, I believe that they're gonna have, I believe they're gonna have the transfer locations on
the 110
graphics.
coming in, right?
That was what I
Well, there's
said.
no 110 coming in
They're gonna have
anymore,
one
but
band
we
graphics.
used the
They're gonna
switch.
transfer
No, I mean, one to the
Right on
he's
the
asking
graphics,
about to
yeah.
the
This
transformer.
I don't
switch
think
is
it's that
it.
way yet.
Yeah.
And the
There was
switch is
discussion
there.
Is
about
there a
it.
switch
Yeah.
Yeah, I was gonna
for
have
the
to
24
search
too?
and, like,
Jimmy,
prints, try to find
There's a
that.
switch at each box too.
Switch each block.
Each
That's what I'm
VAV.
saying. Yeah,
And there's a
I-
switch
wasn't
it,
sure. I
yes.
wanted to make sure I knew what he.
Yeah, that's what I was asking, so you don't have to worry about up there trying to.
Yeah, that's live.
And that's a
yeah.
good
And
thing
I-
that you have it routed into 3 different things, so you won't do a lot of them at the daisy chain failure.
Well, that helps out in communications because, you know, on these floors, you know, you have a lot of sharing
Yes.
of flows and temperatures and stuff, so it picks the network speed up. So, you know, and if you have too much, then it starts bogging it down. You get slow
But that's
update
good
rates
too,
and stuff.
because
So,
if you have a failure in A, B and C should be okay.
right.
So that's not a bad thing.
Do we know how many boxes per transformer?
It
That-
varies, I think.
That's gonna vary, and we'll have when the drawings are all updated, completed on the update, that will all be something that you'll have.
When one transformer fails, we'll find out.
Well, I'd be curious to see, like, you know, if they say there was 6.
Dave one showed me where they are.
You know,
Like
you know
6
that-
might be
There's
typical.
like one
Yeah,
like right
right.
in the
You know,
middle.
but
and
then
there's
you
one
may
in the
find some like
corner,
with
most
4 or
of them.
5, you know.
Well, and there's one like right up the stairwell that feeds that way.
The VA rating of
They're
it,
all pretty much the same.
that's something that we'll have all that information, how many are on it. I think Steve actually went through and shut the circuits off and found out what boxes were actually on each one, so you'll have all that information. That's all available information for you. So,
Talk about radiant panel too. Is there anything to know about the controls of the order of heating between a radiant panel and the reheat? Are
Well,
they
we went-
simultaneous?
we went over that downstairs. Originally, they were, first stage of heat was a radiant panel. Then as the temperature continued to drop, the reheat would start to open. And Steve Fostello would change that out. And he wanted to implement the standard that they were using over on the other side of the hospital to
Which is
here.
simultaneous? Is it-
Which it's gonna be open all the time.
No, it's only gonna be open if it's.
Below and
Well,
outside.
right, it's gonna be open all the time. And then when when the temperature's above the lockout, it's gonna lock all of it out and they're all gonna close. But regardless, if it's below whatever you guys set it at, 50 degrees, 60 degrees,
Outside air temp.
outside air temp, they're gonna be open regardless of the temperature in the room.